here we have a problem on derivative. So there is a function over here, and we have to find derivative of this function with respect to x, because in denominator we have dx. Okay, so if I want to get derivative of this function, first I have to find the derivative of the stuff on the left side with respect to x. So the derivative of this y with respect to x is dy over dx. So how can I get the derivative of this stuff? See here we have a product of two terms, e to the x power and ln x. Both of them are multiplied. Okay, here the two terms are multiplied. If one of them is constant, I will not have any trouble to find derivative of this one, because I can keep the constant as it is and find the derivative of variable alone. But here both the terms contain variable x. So how do you have to find derivative for this kind of stuff? That is, if two variables are multiplied, how do you have to find derivative? So our first try must be, so we should try to multiply these two terms and simplify. But it's not possible, because we cannot multiply and simplify e to the x power times ln x. We have to keep them as it is. So the other option is we have to use the product rule. What is product rule? For example, let us consider the two variables u and v. Both of them are multiplied, and I want to find derivative of this u times v with respect to x, or it's just I want to find the derivative of this product u v. So please consider both u and v are variables. So first what I need to do is I have to keep the first variable as it is, find the derivative of the second variable, then it will become v prime. Then take addition. Now find the derivative of the first variable, then it will become u prime. Keep the second variable as it is. So this is called product rule of derivative. Okay, now I'm going to use the product rule over here. So I consider this is u and this is v. Okay, so now let me do it. So when I find derivative of this y with respect to x, it's just dy over dx. Now, according to the rule explained over here, I have to keep the first variable as it is. That is, I have to keep this e to the x power as it is. Now I have to find the derivative of this ln x prime positive. Now I have to find the derivative of the first part and keep the second part, that is v, as it is. Okay, so here dy over dx equals to e to the x power. So ln x prime means we have to find the derivative. This symbol says prime. Ln x prime means we have to find the derivative of this natural logarithm of x. So the derivative of natural logarithm of x is 1 over, so whatever stuff we have in the argument, that should be taken in denominator. So the derivative of ln x is just 1 over x, positive. So here we have prime for e to the x power. That means we have to find the derivative for this e to the x power. So the derivative of e to the x power is just simply e to the x power times ln x. Okay, here I think we can do further simplification. So the first term, second term, both the terms contain e to the x power. So I think e to the x power can be factored out. If e to the x power is factored out, I have 1 over x left in the first term and ln x left in the second term. Okay, so even I can leave this one as a final answer. Otherwise, I can do some more simplification. So that is how can we add this ln x and 1 over x? You just consider it's a whole number or integer and a fraction. So we are adding a fraction and integer. So whenever we add a fraction and integer, the integer part has to be multiplied by the denominator. So once I am done with this multiplication, I can take this x as a common denominator. So then I will be getting dy over dx equals to e to the x power times 1 positive. When I multiply this ln x by this denominator x, I'll be getting x times ln x. And once I'm done with this multiplication, I can take this x as a common denominator. So dy over dx equals to, I think we can take this denominator x for this e to the x power alone. Then we'll be getting e to the x power over x times 1 positive x times ln x. So this is the derivative of the given function with respect to x.